Hey, what's going on, guys? Let's do this problem right here. The question is asking a cylindrical water tank is having 270 centimeter diameter. So this is 270 centimeter diameter and then 8 meter height. The total height is 8 meter. It's okay. The total height is 8 meter right here, and then the water exists through 1.9 centimeter diameter. So this is diameter right here is 1.9 centimeter. So let's say this is D2, D1. Okay, then what else we have 1.9 diameter pipe located at the bottom of the tank. The velocity of the water existing varies according to 2g c power half, where c is the water level in the tank and g is this acceleration due to gravity. And then tank starts with an initial volume of 40 meter cubes. So this volume is right here. Let's put this sign for v1 because we are going to deal with velocity and the volume. So v1, this I'm giving this sign for the volume, that is 40 meter cube, and drains until it has final volume of 5 meter cube. So this is v2 is equal to 5 meter cube, and these are the information we have. First question is asking what is the initial height of the water in the tank. Let's see how we can find it. So A part. So we have the A part, this volume. So volume 1, that's what I'm going to deal with. Volume 1, I can multiply this one by area times height. So C1 is the question, right? Initial height. So it's going to be Z1 times this area of this circle. So circle times this height gives this volume. So the area of this one is going to be, so let's put A1 first. So this is equal to Z1 times area. Since this is circle 5, we have the diameter right here. So this is going to be 5d square by 4. D square by 4. I can rearrange this equation. Z1 equal to V1 times 4 over 5 d square, right? That is equal to V1 is 40. 40 times 4 over 5, and this is in centimeters, so we have to convert in meter. That's going to be 2.7 meter. So this is multiplied by 2.7 square, and if you calculate this value, this one gives us 6.986 meter. So we have this Z1. So this is 6.986 meter. So that is the answer for the first question. And the second question is asking initial velocity of the water existing the tank. So to calculate that one, so for this one, let's choose V1, velocity, initial velocity, right? So I can use square root of 2gz1 equation. We have acceleration due to gravity, that is 9.81, and we have just calculated this height, that is 6.986, and that gives us this velocity. That comes out to be 11.7 meter per second. So we have done V part. Let's do the C part. Final height of the water in the tank. Same approach. C, we already rearranged this equation. In this case, the only thing that's going to change is the volume and the diameter, right? Or diameter remains the same because still in the tank. So final, we are dealing with the final height. So this is going to be Z2. It's going to be V2 times 4 over 5d square. V2 is 5. That's given right here. Here V2 is 5 times 4 over 5 times 2.7 square. And if you calculate this value, this one comes out to be 0.8733 meter. And that is the answer for this question. Final velocity of the water existing in the tank. Same equation like this. V2 is equal to 2g z2. That's going to be square root of 2 times 9.81 times z2 is 0.8733 meter, and that gives us 4.14 meter per second. So let's do the E part. Maybe use a different color, maybe the E part. Okay, so we have found this one. Time it takes to train from 40 meter cube to 5 meter cube. So let's see how we can calculate. So if you see the mass change of this volume, so d by dt, mass change of this control volume in this tank. Control volume is equal to mass existing. That existing means the flowing out, so it's going down, right? So it's going to be negative mass existing. And if I find that rate, that may give the time. So let's see. So we have d by dt. Mass I can find by area times the height. Okay, rho, area times the height. Let's say A1 times the height, right? Height 1. So area times the height, and the other side we are going to have. So this is rate of change in mass. So we have to multiply here by velocity. So this is going to be rho A2 times instead of velocity I can put 2g z2, right? For this one I can put c1 instead of h. C1. Here we have rho cancels, so that makes everything easier. So here the height is changing. Let's so height is that one is changing, so this is going to be A1 dz over dt. It's going to be equal to, let's take the square root out, so this is going to be minus A2 square root of 2g, and this is going to be z2, right? This is z2 power half. Z2 power half. So we have this equation right here. So what I'm going to do, let's bring all the z to one side. So we have z power half. If I bring this is going to be minus half, and we have a dz right here, and that's going to be minus a2 over a1 square root of 2g and dt. Since we are trying to find this t right here, time is the question. We have dt. Let's integrate these things. So if we integrate this one, this is going to be c1 to c2. This is 0 to t. Right, that's the ratio right here. So let's continue maybe here. So I'm continuing right here. If I integrate this one, what are we going to get? Plus 1, power plus 1, that's going to be plus half, divided by that power, that's going to give us 2z power half, and that is from z1 to c2, right? z1 to z2 is equal to, this one is going to be minus a2 over a1 square root of 2g. If I integrate this one, that's going to be just t minus 0, the 0 to t, so it's going to be t minus 0. Then what else we have? So we have this equation right here. So let's write everything in terms of time. because that's what we are trying to find. So t is going to be equal to minus 2. So this is z1 to z2, right? So this is going to be square root of z2 minus square root of z1. In the bottom we are going to have a1 over a2 times square root of 2g. So this is all we have to plug in. We have z1, z2 right here. z1 is right here. z2 is right here. Area 1 is right here. Area 2, this one. So area 1, area 2. And then what else we need? 2g. So that is just acceleration due to gravity. If you plug all the values, you will get 15,587, and that's the time it takes to train from 40 meter cube to 5 meter cube, and that's how we calculate. I hope you guys like this video. See you next time.